Hello everybody, this is the second tutorial, and what we're going to do here is I'm going to provide you a way of how to complete the intensity of tropical cyclones. So the first thing I really kind of want to do here is, more or less what we're going to be looking at is you're going to be creating a graph using a Microsoft Excel spreadsheet. Now that link that I have right there is real data from a real study. This is the raw data right here of that you're going to be analyzing. I'll explain that more in just a moment. I'm just going to minimize that right now. So I just want to kind of go over some background information first. So in this particular data set, if we look at the directions that I have right here, in terms of climate change, we're going to look at the intensity of tropical cyclones. And a tropical cyclone and hurricanes are synonyms. So if you didn't know that before, you'll know that now. So our research question in this particular case for data set number 4 is, what is the relationship between sea surface temperature and wind power from a hurricane? Now let me explain that a little bit. So what we're trying to understand is a relationship, possibly a cause and effect relationship of how warm the ocean waters are, that's the sea surface temperature, and how intense a hurricane really is. And how we're measuring the intensity or the strength of a hurricane is how much wind power it really has. There are other ways to actually measure the strength of a hurricane, but wind speed is just one of those ways to do so, and that's what you're going to look at in this particular data set. There is a little bit of background information that you should be aware of if you're not very familiar with hurricanes. The first is, again, hurricanes and tropical cyclones are really the same thing. Tropical cyclones, we call tropical cyclones in the Atlantic hurricanes, and as well as the Eastern Pacific. Out in the Indian Ocean, we call them cyclones, and in the Western Pacific, by Japan and the Philippines, we call them cyclones. So, but they're all more or less the same thing. They're all hurricanes. They're just different names depending on location. And tropical cyclones is just a generic name for all of them. So the data from the link above is really focused on the Atlantic Ocean, which is why we're calling them hurricanes. And the wind speed, what we're going to be doing is we're going to call that the tropical cyclone power dissipation, and that's going to be the wind power. In the main development region, that's the part of the globe where the main development region, where hurricanes tend to form, and we're also going to look at sea surface temperature. So right here, I have some key terms that you should be familiar with. A tropical cyclone is really defined as a system that originates over the tropical ocean waters and can develop into a destructive storm, which we call hurricanes, particularly in the United States, as well as Mexico and the Caribbean as well. Power dissipation is really defined as the sum of the maximum 1 minute sustained wind speed cubed at 6 hourly intervals. So I know that sounds really complicated, but basically what that means is wind power. That's what we're trying to calculate, and that's just how that wind power is actually formulated. And that will be for all periods when a cyclone is at least a tropical storm strength. So that means actually less than a hurricane, where you have a minimum wind speed of 34 miles per hour. So we have tropical storms, which is from 34 to 74, and anything above 74 is a hurricane. So MDR, as I briefly described, is called the main development region. And that's the region that's bounded by 6 degrees north latitude, 6 north and 18 north, as well as 20 west and 60 west longitude. And just so you know where that is, I do have a link for it. Right here is the main development region, and that's the area that is highlighted in red right here. So right here is Africa. Right here is North America. There's Florida. Right here is the Caribbean. So this is the main development region where most tropical cyclones begin to form. And eventually they never begin to develop, they never form out here. That's not the main, if they can, but typically most hurricanes, tropical cyclones form right in this region right here. Excuse me. And the primary region is, the reason is that it's warm. Excuse me. Okay, so what we're going to do is we're going to follow. Now, if you have an old version of Excel, you're going to have to follow these directions, which I'm not going to give directions for. If you have the latest version right here of Excel, this is how you're going to make your graph. And I'm probably going to give you a little bit more information here than you kind of need. I definitely want you to make up your, create your own graphs, but I'm going to pretty much do a lot of it for you. I'm going to at least show you how to do it because it's kind of hard and complicated. So I'm going to have the data right over here that I already had uploaded when I clicked on this link over here. So what I want you to do first, you can see right here, is highlight all the data, including year, the MDR SST, that's the main development region, sea surface temperature, and the power dissipation, which again is that wind power. So this right here is the year from 1949. This is when all the data was collected to 2009. There is a little bit more recent data, but I want you to use this. It's a little bit easier to use. Right here is August to October because those are the months where most of the hurricanes actually and tropical cyclones develop. And right here is that wind speed, power dissipation. And as you can see, these are very, very, very large numbers. So, what we're going to do is we're going to correlate these two factors over time. So in order to really do that, we're going to be looking, we have to create a line graph because what we're really doing is understanding the relationship of two factors over a period of time. Scatter plots are really relationships between two different factors. Here we're looking at change over time, and we're going to look at to see if there's a correlation between these two rows right here. Okay. So what we're going to do is we're going to highlight, as I have in the directions right here. You know what? Let me just start right here. And I highlighted everything from that data table. And again, this data is from a scientific research paper. So if we look right here, I already completed number one, highlight all the area, highlight all the data, blah, 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 like I did. And then you're going to do is click on Insert tab. So right here is the Insert, and we're going to create a graph. So right here are all the different types of graph. We have bar graphs, pie graphs. Here's a scatter plot. But as I said, we're going to be creating a line graph. And because we're seeing how these factors change over a period of time. Because we have two factors, we're going to do what's called a stacked line graph, which I'm going to collect right here. Now, I'm not sure why Excel does this, and I tried a lot of different ways. It doesn't organize it right. So right here, you can see this data right here is the power dissipation, and in red right here is the sea surface temperature, but it doesn't have any of the data graphed correctly. So what I'm going to do is I'm going to go right here, as the directions stay over here, is I'm going to click on Format Data Series. And what I'm going to do is I'm going to click on Secondary Axes. And what that does is it puts that data on the y-axis as a secondary one, and cross that out. And you can see right here, the red is the sea surface temperature from the main development region where hurricanes form. Here, right here, you can see is the temperature. That temperature is in Celsius, by the way, so that's a little bit easier to understand than the power dissipation right here, which are huge, huge numbers. So we have this right here, and you notice we have a key. We have the year right down here, and what I tend to do is, since we don't really need to see that, I kind of delete that. So the one thing that is problematic right here, we need to fix the horizontal x-axis. It jumbles all these numbers up, and I'm not sure why it does this, but this is a pretty easy fix. What I'm going to do is I'm going to expand this a little bit further out, because what I want to do is click on this right here and select data. For some reason, this right here, the horizontal or the x-axis, doesn't show the data right here. And I still cannot figure out why it does this. But, an easy fix is just to really highlight this data right here. Oops, went too far. Let's go back up. And just highlight from 1949 to 2009, which I did. And now you can see the x-axis does have data right here, and I'm going to hit OK. And that graph should fix. And you can see right here, now it's 1949 to 2009. I don't know why. And I don't like that blue line there, so I delete that too, because that came up originally. I'm going to make it a little bit, make this graph a little bit bigger. Okay, so now I have the graph right here, and I have all the data here. Now, the only thing that we're really kind of missing is the label. So if you go right over here where it says add, or actually, I'm sorry, quick layout. No, let's not do that, because we already have the title right here, which you could just click onto it and change the name of my title. I'll let you put a title in there. But if you notice, this is not labeled, this is not labeled, and this is not labeled. So what we want to do is, oops, I keep on doing quick layout. I want to add a axes title. So we want to add a primary one, which will add this on the y-axis over here. Another axes title, the secondary vertical, which will add it over here. And then I want to put year down here. That way, even though it seems kind of obvious, axis title on the primary horizontal. There we go. So that's right there. We don't have a secondary one. And again, I'll add this right here. All you need to really do is add year. And there you go. And we still have a key right here. So that's basically it. That's how you create the graph. I'll let you add in the titles and stuff like that. But that's basically how you create the graph. And that's what you're going to save in your Google Drive folder. So if I go back to the PowerPoint, well, right here to online, right, week 3, the PowerPoint, the instructions, directions, which again, I only have 2 slides. So basically, after you collect data set number 4, you do create the graph. You're going to provide a little bit of analysis for it in your table, in your summary table, like you did with the other 2. And then just bring everything in next week. You don't have to do that last column with the initial explanation yet, because we're going to do that when we meet in person during week 4. So if you don't have any other questions, hopefully this helps, and have a good week, and we'll see you on the 10th.